Hey team, it's Mr. Z, and today we're going to take a step back and just talk about some good mathematical practices. Remember, the whole reason you're learning math to begin with is to train your brain to represent the world, just like you represent the world in writing in English class. In math class, you're going to try to represent the world differently and just try to understand that there's a lot more questions to ask behind the surface. So, let's go ahead and take a look. All right. So pause, take a moment to read the slide and read it on your own. But basically, I'm taking a moment to really just show you that, like, all of the things I do where I go off script and I'm just doing math in a work product area where I draw a graph, where I draw a picture, where I write out an equation, all of this is called the modeling process. And this is where you have proficiency or where you don't. This is where you truly show your understanding, because what you need to do for all of these problems is you start off with a blank plate and then you fill it up. You fill it up, and the idea is once you start going, you're going to reveal more and more steps to go. So let's go ahead and try to look at this in terms of last time. So basically, in this last activity, we started to think about the drains, right? And the key question that was driving us is, how do I turn a metal sheet into a sewer grate? So the way we did that is we drew some pictures. We started off with a metal sheet of metal, and we decided I'm going to take the same piece of metal and I'm going to fold it both sides, creating something that looks like this. And voila. Then we were like, well, what happens if I take the same size sheet of metal and I want to fold it further in? That would cause the sides to go up. And likewise, I can go real extreme and take my folds and go nearly near the center, resulting in a metal grate, like so. This is just theory and understanding the application, and this is where we've been jumping. A lot of this class has been preparing you to think about real-world situations. But really, I'm just taking a piece of metal and I'm folding it. All three of these rectangles form a cross section. If you want to think of this as a dashed line, all of these are rectangles. The cross section is a rectangle. We're missing the top. However, the way to find it is the same. But, okay, all of them are rectangular cross sections. And the reason why it's a cross section is because I'm taking a flat piece of metal and we're jumping into the world of 3D. Now, how do I use my pictures? How do I use my pictures? You start with your givens. So let's go ahead and start labeling some of these guys. I have a picture. It's 8.5. And let me go ahead and fold it 1 inch in. Or it's actually feet, so it's 6.5. How did I get that? Well, if I fold one part in, I subtract it, and I subtract it. What would this kind of look like? Well, it would look like cross section was 6.5. I'm going to only write the 1, and I know that this is an area. So to find the area of this guy, I would have to do 6.5 times 1. Okay, let me try it again. Let me take the same piece of metal that I start with, and let me fold it 2 feet in. 2 feet in. So I'm going to have to take 8.5 and subtract 2. Subtract 2, and I get 4.5. This is going to create a rectangular cross section with the following dimensions. And to find the area of that guy, I would have to do 4.5 times 2. Okay. Now, the problem is I am the engineer. I need to figure out which one of these areas is going to result in the most sewer grade. What I wanted to find out is the maximum sewer grade. I need to figure out how can I take a sheet of metal that is 8.5 feet long and turn it into the most sewer grade for the taxpayers. Get the most bang for your buck. In order to do this, I need to look at all situations. Notice how in each of these processes that there was a formal part where I would subtract each side from the starting amount. So if I want to think about it again, I started out with 8.5, and this time I want to just cut it an amount, and I'm not going to say what number, and I have to do it to both sides. So it would be H and H. Now I could use X here, but the reason I'm using H is because later on, this is going to be the side length. So I'm going to use height because that's actually what it represents, and I don't want to confuse myself, but any letter at this point would be appropriate. Okay, now remember the process. To find out what this length is between it, you're taking your starting amount and you're going to subtract it twice. Algebraically, I can rewrite it a little cleaner, like so. Although this is an expression and it's not a number, when I plug in the height, that's going to give me the answer. Look at the previous two examples. If you were to plug in 1, 8.5 minus 2 is 6.5. If you were to plug in 2, 8.5 minus 4 is 4.5. So, even though this isn't a number, it's okay. It's an expression. I can figure this out, and this is going to be key. This is going to resemble all possibilities. The reason being is I was able to write out a function. This is going to be a function that represents each one. The area of this rectangle would be my height times 8.5 minus 2h. This represents all possibilities. Okay. So it's like we're just kind of going in the dark and we're playing around and we're just really understanding that, hey, from this, I have an area formula is base times height. I am just multiplying my base. I am just multiplying my height. So now I have to figure out how do I use this to my advantage. So I'm going to predict and analyze. What I'm going to do is I will use technology to graph the function. And it's going to reveal something that looks like so. It's going to have a vertex, which is also the axis of symmetry. And this point is 2.125, comma 9.03125. That's it without rounding. Desmos will usually round it to 3 digits automatically. So, okay, I will use technology to graph the function. Now, the reason why I'm looking at this specific point is you have to remember what I'm searching for. I want to find the maximum area. I want to find the greatest amount of area. The output, the y's, the answers is all area. So, for example, if I compare this point and if I compare this point, the light blue base and height, whatever they are, is going to have a bigger area than the green point. The dark blue point is going to have a greater area than the light blue point. If I continue, notice how the dark blue one is going to still be higher above. It's going to be a higher number than the red point, and so on. The red point has a higher area than the green point, and by using technology, I can get those exact specifications. But the maximum is going to be the biggest area. It's going to be the most in the Y value. And you have to remember what we're dealing with. Here, my input was H, and my output is f of H. In this situation, that is the height, and what comes out? The area of the cross section. What is 2.125? The height. What is 9.03125? My area. So these points are just numbers anymore. They're representations of 1,000 different situations. Think of this as your crystal ball, and you're looking at it with your eyes and you're trying to see into the future. And instead of having to do a bunch of area problems, you're able to look at it visually and identify the best situation on a dime. So now at this point, we got to just kind of really just like, again, get our answer because we've just been going off script and just thinking about a situation. We want to create a model to clearly display our answer. So I'm going to go ahead and draw one. Boom. Here we go. Now, the cross-sectional area is going to be here. And the area is typically written on the inside because that's what area is, the number of square feet inside of a figure. So the area is going to be 3125. The height is still going to be here. What was the height that we found? Well, the height is 2.125. It does leave us with something else. What is this? This in the past was 8.5 minus 2h. So to figure out what the heck this needs to be, I'm going to do 8.5 minus 2 times 2.125. Notice where the height came from. This is going to be 4.25. So voila, I have my cross-sectional area. I have a nice diagram to turn in. And basically, our answer is the height must be 2.125 feet to produce sewer Creates with the maximum area. Hope this helped.